Welcome to Tungala online classes. So we are discussing motion and strength in chapter. Last class we discussed regarding freely falling body. So today we start the vertically projected body. Before starting this vertically projected body, one last point related with this freely falling body. So that one is, let us consider a well. So then in this well, let us suppose water was there. So up to a depth of x value. Now a person dropped one stone from the top of the well. Water is there at a depth of x. Now what we want to calculate is, so we want to calculate what is the time after which the splash of sound will be here. Time taken for hearing the splash of sound. So now dropping the stone. So dropping the stone, I want to calculate the total time taken. Stone is freely falling body. Yesterday we have discussed. So what is the time taken by the stone to hit the free surface of the water? So that is given by root over 2 into h divided by g. But after hitting immediately we will not hear sound. So actually the sound which is produced again it reaches to top. Here any observer is there. So for this observer to hear the splash of sound, the sound should travel again in distance of h. Then what is the time taken by the sound to travel this distance h? So time is equal to distance traveled by velocity. What is the distance value h divided by velocity given by velocity of sound. So this is the formula to calculate the time after which the splash of sound will be heard. Okay na? So this is the points which are related with the freely falling body. After completion of freely falling body, now let us discuss vertically projected body. Vertically projected upward body. Whenever a body projected upwards. So now first let me write what are the equations of motion. Kinematic equations for which body? For a body which is projected vertically upward body. In case of vertically upward body, so let us consider a body which is projected vertically upwards with the initial velocity u. So here initial velocity is not 0, it is u only. And what about regarding acceleration value? Body going vertically upward direction against the gravity. So a value already discussed yesterday class is equal to -g. Now substituting these two values in general kinematic equation. So what is the first equation we get is general formula of first equation v is equal to u plus at. Now let me substitute here. So what will get the answer is v is equal to u minus g into t. So this is the equation for first equation for vertically projected body. The velocity of vertically projected body which is projected with a velocity u after t seconds is given by v is equal to u minus g into t. So here velocity with the time decreases. So u minus gt with the time velocity value is going to be decreases. For example, so if at 1 second velocity value v1 is given by u minus g because t value is equal to 1. So this is for t is equal to 1 second. If I take t is equal to 2 seconds, so what is the velocity we will get v2 is equal to u minus 2 into g, which is nothing but v1 minus g. So what does it mean? For a body which is projected vertically upward, so velocity every second will be decreases by how many units? G units. If I consider v1 for example, the velocity of vertically projected body at the nth second of its journey is v. So what is the velocity at n plus 1 second? That is of v minus g. What is the velocity n minus 1 second? That is of v plus g. So with the time what happened to velocity? Decreases. For which body? For vertically projected upward body. So this is the first equation for vertically projected body, and what is the conclusion we got it is, so velocity with the time is decreases by how many units of g units. So after completion of the first equation, what is the second equation general form? S is equal to ut plus half into a into t square. Now substituting the values, S is equal to how much I get? Ut minus half into g into t square. So here also distance covered by the vertically projected body with the time is decreases with the time. So with the time it is going to be decreases. So this is the second equation for which body? For the body which is projected vertically upwards. After completion of this, so what about the third equation? Third equation general formula given by, so v square minus u square is equal to 2 into a into s. So here what I get, v square minus u square is equal to minus 2 into g into s. Otherwise v square is equal to how much? U square. So minus 2 into g into s. So this is the expression for final velocity of a vertically projected body after traveling a distance. Yes, the final velocity of vertically projected body is given by. So with the distance, what happened to final velocity? It is going to be decreases. So this is the third equation, third kinematic equation for vertically projected body. And what about the fourth equation? So fourth equation, Sn is equal to distance traveled in nth second of a journey. Formula given by Sn is equal to u plus a by 2 into 2n minus 1. So this is the general formula. For vertically projected body, what will get? Sn is equal to u minus g by 2 into 2n minus 1. So this is the fourth equation of motion for vertically projected body. Distance traveled in nth second is going to be decreases. So here also, if yes, h is the distance traveled in nth second of its journey, so distance traveled in n plus 1 second of its journey will be h minus g. So distance raised by the vertically projected body, so with the time is going to be decreases by in successive intervals. So by how many units is going to be decreases by g units. If I consider distance traveled at nth second is h, distance traveled at n plus 1 second will become h minus g, and distance traveled in n plus 1 second will become h plus g, similar to that of this first equation. So velocity decrease, distance traveled for the total time of journey decreases, final velocity decreases, distance traveled in last nth second also decreases for vertically projected body. So this is for vertically projection. Let me consider first one. Okay now? So kinematic equation for vertically projected body. Now let me see some important points which are related with this vertically projected body. The first point regarding this vertically projected body. So I will write first point. So what is that is maximum height. Maximum height. So is represented by h max. What is maximum height? A body projected vertically upwards. So with the velocity, already you know the derivation, but just so body projected vertically upwards with the velocity u. As we know that when body going vertically upward direction, its velocity going to decreases at one particular point. So where final velocity will become 0. Where final velocity is 0, that point is called as maximum height. So just in order to find out the maximum height, so s value will be equal to h max, and u value is equal to u only, and v value is equal to 0, and a value is equal to minus g. Substituting all these values in which formula? In v square minus u square is equal to 2as. So I will get the answer 0 minus u square is equal to minus 2 into g into h max. From this, what I will get h max is equal to? So h max value is equal to u square divided by 2 into g. So this is the expression for maximum height. So maximum height reached by which body? Vertically projected body. What is maximum height definition? Maximum height is the point at which the final velocity of vertically projected body will become 0. So actually this maximum height depends upon initial velocity and acceleration due to gravity. As we considered yesterday, so acceleration due to gravity constant on the earth's surface. When acceleration due to gravity is constant, so maximum height is directly proportional to u square. With increasing the initial velocity, maximum height also increases whenever g value constant. For example, now body projected with the same initial velocity but from the different planets. So u value constant, that time the maximum height value. This is when if so g value is constant. If g is constant, then we will get it. So that is. Otherwise, so h maximum is inversely proportional to g. So when we need to apply this formula, whenever if so u is constant, whenever a body projected with the same initial velocity but from the different places or different planets. So in this way you can calculate the maximum height. So after calculation of maximum height, so next one is, I am not deriving the remaining derivations, so directly I will write. What is the meaning of time of ascent? Time of ascent is the body projecting vertically upward direction. So what is the time taken by the vertically projected body to reach the maximum height from the ground? Now projected from A, it has reached to B. In order to reach the maximum height, so what is the time taken? That is called as the time of ascent value. So TA value. Directly getting time of ascent TA is equal to formula U divided by G. So what is time of ascent? Time taken by vertically projected body to reach the maximum height. So time of ascent descent depends upon initial velocity and the G value. After completion of the time of ascent, so next one is third point. What is time of descent? Time of descent. After reaching the maximum height, again the body which is projected vertically upwards will fall from the maximum height only. So what is the time taken by that was freely falling body to reach the ground from the maximum height? So that time is called as time of descent, which is given by TD. TD is equal to U. So time of descent also depends upon initial velocity and acceleration due to gravity. So actually here time of ascent and time of descent both values are same. When time of ascent and time of descent both are same means when air resistance is not considered. When air resistance is not there, the time of ascent value and time of descent value both are same. If air resistance is there, what happens we discuss later. So that is the calculation of which one? So time of descent value. So after calculation of time of descent, now next we will discuss regarding so what is time of flight. Third point is over. Fourth point is time of flight. What is time of flight? Time of flight represented with capital T. It is the total time taken by vertically projected body to reach the ground. Now body projected from where? From the ground. It will reach to maximum height. Again it will fall from maximum height to ground. What is the total time? How much time the body will be there in air? So that time is called as time of flight. This time of flight is the sum of time of ascent and time of descent, which is given by TA plus TD. So which is given by 2 into U divided by G value. 2 into U divided by G value. So that is the expression for time of flight. Time of ascent, time of descent and time of flight. So we can also express this maximum height in terms of time of flight also. So what is the expression for time of flight? We got T is equal to 2 into U by G value. From this U value is equal to T into G by 2 value. If I substitute the U value into formula H max, so I will get H max formula is equal to H max is equal to, so what I will get the answer is T square into G divided by 8. This is the expression for which one now? Maximum height in terms of time of flight. So time of flight can be also calculated when they given maximum height can be calculated if they given the time of flight. So this is maximum height, time of ascent, time of descent and time of flight value. Okay, clear now? So after completion of this, I told to you. So now we discuss in the presence of air resistance. So which one will be greater, which one will be smaller? Time of ascent is greater or time of descent is greater? So let me consider the point number 5. So in the presence of constant air resistance, capital R. Let me call the resistance value capital R. So let us suppose a body projected vertically upwards with a velocity u in the presence of constant air resistance. So then afterwards the body will go to maximum height. Again the body will fall down. So body reaches to the ground with a velocity, let me call v. So what is u and what is v? The body projected with a velocity u and body reaching the ground with a velocity v. So here y velocity of projection, velocity of landing or reaching. So y not same means because of the presence of air resistance. In the presence of air resistance. Now let me calculate what is the value of time of ascent and what is the value of time of descent. First, I will consider during upward journey. For upward journey. During upward journey, so what are the forces acting on the body? When body going up, which are the forces which oppose the motion of the body? Air resistance will oppose the motion and gravity. So weight of the body also acting vertically downward direction. So what are the net opposing forces acting on the body are given by, so a gravitation force mg and also air resistance r. So net definite according to Newton's second law, so can I get it as m into a dash is equal to mg plus r. From this, what will get the a dash value? A dash is equal to mg plus r divided by how much? By m. So this is the acceleration. Acceleration of which body? Acceleration of a body which is moving in the presence of, in additional with air resistance, in additional with the gravity, so air resistance. For example, if air resistance is 0, acceleration will become g only. So but here air resistance is there. Now what I want to calculate? Time of ascent. Time of ascent means, so final velocity will be 0. Initial velocity u only. And that time acceleration value how much we got? A dash value mg plus r divided by how much? M. So what I want to calculate? T value how much? Can I calculate? Can I call time of ascent is T? Substituting all these values in the formula. So V is equal to U plus AT. V is equal to U plus AT. So from this we can able to calculate which one? TA value. By substituting the values here I will get, so T value is equal to TA value is equal to M into U divided by, so mg plus r. This is the expression for time of ascent when in the presence of air resistance. So whenever air resistance is present, time of ascent value also depends upon mass. So TA is equal to M into U divided by mg plus r. This is for time of ascent. Similarly, we can also calculate the time of descent value. Which value? Time of descent value. So time of descent. So that is for which journey? For downward journey. For downward journey, so time of descent value I want to calculate. Whenever a body is coming down, so what is the velocity with which the body reaching the ground? V. What is the initial velocity value? 0. So air resistance will be in what direction? Vertically upward direction. Gravity in the what direction? Vertically downward direction. So what is the net force acting value given by? F net is equal to mg minus r. From this I will get a dash value is equal to mg minus r divided by which one? By m value. So this is the acceleration of which body? A body, if the body is falling down. So then by substitution in the similar formula, we get the expression for TD. So TD will be given by m into v divided by, so mg minus r. This is the expression for time of descent. Okay. So time of ascent value and the time of descent value. So which value? How much value we got time of ascent? Time of ascent is m into u by mg plus r. By comparing these two, actually what is the general formula for time of ascent? In the absence of air resistance, so TA TD is equal to u by v. But now values will become m into v divided by mg minus r, m into u divided by mg plus r. In the presence of air resistance value, both the time of ascent and time of descent increases. But so which will be greater and which will be smaller? So this is the value of TA, that is the value of TD. So TD value will be greater than which value of TA. So what does it mean? Time taken by the body to reach the ground from the maximum height. So will be more compared to the time taken to reach the body from the ground to maximum height. So time of ascent value greater than which? Time of descent value greater than which value? Time of ascent. Even we can also calculate the final velocities also. So what are the final velocity given by? So the ratio of the final velocities we get, v value is equal to root of, so mg minus r. So directly together I will write this square root, which is equal to root over mg minus r divided by mg plus r. We can calculate the final velocities. Here one point we are remembering, though in the presence of air resistance also, height of ascent value, height of descent value both are same. So then h value will be same. Then we can calculate the final velocity and initial velocity by knowing acceleration value. Upward journey acceleration I know. Upward journey initial velocity value u. Distance traveled if I call it as h, then I can calculate the velocity value. Similarly for downward journey. So I will get the answer v by u value is equal to mg minus r divided by mg plus r. So v value less than which one? U value. What does it mean? So for a body is projected vertically upward direction. So velocity of reaching the land will be smaller than the velocity of projection. That is because of the presence of air resistance. Okay now. So till now we are discussing for which body? For vertically projected upward bodies. In case of vertically projected upward body, in the absence of air resistance, time of ascent value, time of descent value both are equal. Whereas in the presence of air resistance value, time of descent is greater than which one? Time of ascent value. Okay now. So that is for vertically projected body. In this vertically projection only, we shall discuss in the next point. Vertically projected upward body. Only the thing is, if you get it the concept clearly, so problems can be solved easily. Okay, maximum number of problems you should be capable to solve it. So after completion of this, under this vertically projected body only, so I will consider the second point. So what is the second point? So let us consider a tower. From the bottom of a tower, a body projected vertically upwards with a velocity u. Let us consider a point P. So height of the point P, let me call it as h. This vertically projected body, first it will go vertically upward direction, again it will come down. This body which is projected, it will cross the point P twice in its journey. Once while going up and again while coming down. Now let us suppose from the side T1 is the time taken to cross the point P once, T2 is the time taken to cross the point P second. Question point get it? A body projected vertically, so vertically upward direction, crossing a point twice in its journey. So one is for the time interval T1, other for the time interval T2 from the start. Now I want to calculate what is the height of the point P and what is the maximum height up to which the body projected. So can I write here what is the initial velocity u value u only. So a value is equal to minus e. So what is the height of the point P? H. Okay now, height of the point P value will be equal to h value. Then time intervals are given. Substituting these values in the formula, so v is equal to u plus a. Or otherwise, I will substitute the values in s is equal to ut plus half a t square. S is equal to ut plus half into a into t square. Here s value is equal to h. H is equal to ut minus half into g into t square. From this what I will get? I will write it as g into t square minus 2 into u into t plus 2 into h is equal to 0. This is one quadratic equation. This quadratic equation roots will give you t1 value and t2 value. Where t1 is the time taken to cross p once, t2 is the time taken to cross p twice. Then in this quadratic equation we know sum of the roots are given. So what is t1 plus t2? What is the formula for sum of the roots of a quadratic equation? Quadratic equation sum of the roots formula. So is equal to minus b by e. General formula write it as minus b by e. Here what is b value? 2u. Minus into minus plus. By a value how much of g? Therefore what is the value I got? t1 plus t2 is equal to how much I got? 2 into u divided by g value. From this, what is the value of u is equal to? U is equal to g by 2 into which one? t1 plus t2. So what is u? Velocity of projection. Whenever a body projected vertically upward direction, crossing a point twice in its journey, in the time intervals of t1 and t2 from the starting, how can we calculate the velocity of projection? So that is given by g by 2 into which one? t1 plus t2. So after calculating this, what is the formula for the product of the roots? t1 into t2 value is equal to. So t1 into t2 is equal to, you know, formula c by a. What is c value? 2h. By a value g. Therefore what I get the answer? t1 into t2 is equal to how much of 2 into h divided by g. From this, what is h is equal to? H is equal to g by 2 into t1 into t2. or otherwise I will write h is equal to 1 by 2 into g into t1 into t2. What is h here? H is the height of the quantity. Means whenever the time interval during which the body crossing the point be given t1 and t2, what is the height of the quantity given by h is equal to half into g into t1 into t2. But remember here, body not reaching to final point p only. Beyond p also it is going to some height. I want to calculate what is the maximum height. Maximum height reached by the body. So we know the formula for maximum height. What is h max formula? So h max is equal to u square divided by 2g. What is u value here? We got 1 by 2 into so g into t1 plus t2. By substitution we get the value which is equal to so g by 8 into t1 plus t2 whole square. How much? G by 8 into t1 plus t2 whole square. So this is the expression for h max. How we will get h maximum formula? By substituting u value. So u is equal to g by 2. G by 2 whole square. So g square by here I will get the value of 4. So g square by 4 into t1 plus t2 whole square by 2. Then I will get h maximum is equal to g by 8 into t1 plus t2 whole square. So this is the maximum height formula. So this concept I think clear. Body projected vertically upward direction, crossing the point B, tracing its journey. Then what we calculated? We calculated the velocity of projection. We calculated the height of the point B. Then we calculated the maximum height. Okay? And that is vertically projected upward body. So let me discuss the third point. Another point we discuss, that is point number 3. Okay na? So third one. In this, now let me consider a tower. The tower of height value, let me call it as h. From the top of the tower, a body projected vertically upward direction with a velocity given by u. Then what happened to body? Body will go certain height, again it will come back. Again it will fall down, reaches to the ground. Okay. Now what I want to calculate is, so I want to calculate here what are the points, what is the time taken by the body to reach the ground, and what is the velocity with which it will reach the ground, and what is the height of the tower value I want to calculate. First let us call the body going to certain height. So let us call body reaching to a distance of, I will call this distance value is s. S distance it travel vertically upward direction. Again it will fall down s distance. Again it will travel the h value. What is the net displacement value? Net displacement value. What is net displacement value given by? Actually here we will consider a sign convention as per the coordinate axis. Whenever sign convention with respect to coordinate axis, whenever a body going vertically up along positive y axis we will take plus, vertically down along negative y axis we will take minus. First body going vertically upwards covering a distance of s. Again it is coming down covering a distance of minus s. Again minus h. Why we taken minus h value? Falling down, coming down, displacement value minus h. So total displacement will be equal to minus h. How much? Total displacement value is equal to minus h. What is the acceleration value? Minus e. Substituting these values in which formula? S is equal to ut. So ut plus half into a into t square. So what will get the value? That is 1 by. So minus h is equal to, here actually can I call the net displacement value here? So net displacement is s dash. Minus h is equal to what will get here? So minus h is equal to ut minus half into g into t square. Otherwise I can write it as h is equal to minus ut plus half into g into t square. This is the formula to calculate the height of the tower. So remember, so this is the formula when it is applicable whenever a body projected from the top of the tower time. So what is the height of the tower value? When they given the total time taken to reach the ground, then we can calculate the height of the tower. So this equation is quite somewhat different. Generally we write h is equal to ut minus of t square, but here h is equal to minus ut plus half into g into t square. So roots of that equation will gives us time. We can calculate the time taken. What is the time taken to reach the ground? Time taken to reach the ground. To reach ground. So that time taken is given by roots of that equation only. That is t, and get t is equal to, I am writing directly. So u plus root over, so u square plus 2 into g into h divided by, so g. This is the formula to calculate the time taken. We needed this formula while doing the problem. So t is equal to, by that roots, finding the roots, you know that na, minus b plus or minus root over b square minus 4ac divided by 2a. By using that formula, the roots of this quadratic equation you can calculate. Time taken. So okay, after calculation of time taken, what is the velocity of reaching the ground? Velocity with which reach the ground. Reach ground. What is the velocity with which it will reach the ground? So velocity one need to calculate general formula, v square minus u square is equal to 2a. Here what happened? u1 is 0. So v square is, u1 is not 0. Projected with the velocity u. So v square minus u square is equal to 2 into a value minus g, s value minus h. So then what will get the total formula? That I will get the, so v square is equal to u square plus 2 into g into h. So this is the formula for final velocity. What is the final velocity with which the body reaches to the ground? That is given by, so v square is equal to u square plus 2 into g into h. Okay na? So these are the projection from the top of the tower. Just one example for the projection from the top of the tower. A balloon is ascending up. So with a velocity v, from the balloon, if they drop a stone, so then what happens? The stone first it will go vertically upward direction, again it will fall. Then what are the equations we written? The same equations are applicable to calculate the ring. Okay na? So that is for, and remember in case of the balloon, okay, that point also discussed. So under this only, for this projection from the top of the tower, what we are considering is a balloon is ascending. So balloon is ascending with a velocity how much? U. So from this balloon we drop one stone. So that is also similar to the projection from the top of the tower. So now what happens? With respect to the, first the stone will go vertically upward direction, then again will fall. First with respect to earth. So what is the equation given by? Minus h is equal to ut plus half into minus half into g into t square. Because with respect to the earth, the balloon will, the stone will go vertically up, again it will fall. So if I want to write with respect to balloon, so what happens? Stone will fall vertically in downward direction. So that time h is given by half into g into t square. Okay now? Because with respect to balloon, stone is a freely falling body whose initial velocity is 0. So when u1 is 0, h will get half into g into t square. Minus h is equal to minus half into g into t square. Okay now? So that is with respect to balloon. Balloon cases also considered similar to that of projection from the top of the tower. Okay, so this is the another point related with the vertically upward direction projection. After completion of this, so next point we will discuss. That is point number 4. So let us consider a tower. So tower of height value, let me call it as this. From this tower, first a body projected vertically upward direction with a velocity u. It has taken a time, so it will go vertically upward direction, again it will fall. The time taken by the body to reach the ground is t. Okay, second time from the same tower, so same height h only, a body dropped downwards with a velocity u. The time taken value is equal to t. Whenever the body thrown downwards with a velocity u, how much time it taken to reach the ground is t2. And third case is, now from the same tower, body, so dropped freely. Dropped freely means u value is 0, the time taken value is t2. What is t1 value, what is t2 value, what is t3? t1 is the time taken by the body which is thrown vertically upwards from the tower of height h. t2 is the time taken by the body which is thrown from the top of the tower vertically downwards with the velocity u. t3 is the time taken by the freely falling body from the top of the tower to reach the ground. Now I want to derive the relation between t1, t2 and t3, and also I want to calculate the value of h. So now actually with respect to projection from the top of the tower we know minus h is equal to, so u into t1 minus half into g into t1 square. We know that now y minus h as per the sign convention. U into t1 minus half into g into t square. Can I call it as equation 1? And in case of the second body, so h value is equal to vertically projected body with the initial velocity vertically downward with the initial velocity u. So then what I get the answer? Value equation u into t2 plus half into g into t2 square. Why I written plus here? Because body moving vertically downward direction. What about in case of freely falling body? U value 0. Third case, half into g into, so that is of t3 square. T3 square. Can I call it as equation 3? Now, to obtaining the relation between the t1 and t2, so what I am doing is, equation 1 is multiplied with the t2 and equation 2 is multiplied with the t1. Equation 2 is multiplied with the t1. So what will get the answer? H into t2 is equal to minus h into t2 is equal to u into t1 into t2 minus half into g into t1 square into t2. Similarly, equation 2 multiplied with t1. H into t1 is equal to u into t1 into t2 plus half into g into t2 square into t1. So I got these two equations. Now I will subtract these two equations. Minus, minus, here minus. This term will be cancelled. So what will get minus h into t1 plus t2 will be equal to here minus half into g into, in both the terms I am taking t1 t2 common, then I will get t1 plus t2. So then minus minus cancel here, t1 plus t2 cancel, then I will get the value h is equal to, so 1 by 2 into g into t1 into t2. So this is the formula for height of the tower. We can calculate the height of the tower whenever they given t1 value and t2 value. What is t1 and what is t2? Know that now? So similarly, can I call it as equation 4? By comparing equation from equation 3 and 4. From equations 3 and 4. So here also x value, there also x value. What can I write? Half into g into t3 square is equal to half into g into t1 into t2. Then half g cancel. So t3 is equal to root over t1 into t2. Therefore, whenever they given the t1 value and t2 value, we can calculate the t3 by the formula. So t3 is equal to root over t1 into t2. And we can also calculate the velocity of projection. That velocity of projection for this one. The velocity of projection formula I am writing here. That velocity of projection value will be given by, so u is equal to g by 2 into t1 minus t2. How will we get this velocity? We will get this velocity, so by using that equations, so 2, 1 and 2. We will get final velocity expression is given by u is equal to, velocity of projection given by g by 2 into t1 minus t2. Okay, so this is the another point related with which one? So related with the body projected from the tower, projection from the tower. So 3 cases we discussed. Okay, so this is for vertically projected body. till now. So maximum, except one graphical case, maximum number of synapses we completed. Tomorrow we'll discuss regarding that graphs. Then tomorrow itself, so we'll start numericals of this chapter, motion in a straight line. Get ready with the numericals of the material. First go through the class synopsis clearly. If the concept is understood clearly, so you should able to solve the problems your own. Okay, na? So thank you.